Hello, everyone. This is Elisa Baum. I'm Grid Gain Systems Director of Product Marketing. We'll begin in just a moment, but first I need to conduct a little bit of housekeeping. If you can hear me clearly, can you please raise your hand using the hand icon on the GoToWebinar control panel? Let me see. Do I see hands? I see hands. You guys are great. Thank you. Next, during this webinar, you will be on mute. But should you have any questions for the speaker, please go ahead and enter them in the GoToWebinar questions panel. And then at the end of the discussion, I'll take as many questions as we have time left for the speaker. And then all the questions will be sent to the speaker as well after the show. In addition, I want to let everyone know that this is being recorded, and I will be sending a recording to everyone who is registered, within 24 hours after the show ends. And I'll also send you a link to the slides as well. So if you have to drop off unexpectedly, don't worry, I'll send you the recording. I understand how that goes. So with that said, I'd like to introduce you to today's speaker, Dennis Magda. He is Grid Gain Systems Director of Product Management, but he's also the Apache Ignite PMC Chair. And he'll be presenting part one in our two-part series, In-Memory Computing Essentials for Architects and Developers. Very excited to have you, Dennis. Go ahead.
Thanks, Elisa, for the introduction. Hello, everyone. Thanks for jumping on this call, because I think that it will be really useful for all of you, regardless of your experience and regardless of how are you familiar with Ignite or other distributed systems. The goal of these two series webinars is to explain the fundamental things about in-memory computing platform and distributed databases. And my goal is not only, to give you only, provide you only the theoretical information about such systems, but also to show how you can quickly start using them in your own environment. Throughout these two series, I'm going to explain you basic things, basic building blocks or notions about distributed systems and in-memory computing. And at the same time, I'll show how you can leverage from them immediately by running different simple examples or code samples. So let's move on. And what do we have for today for our first part of the in-memory computing essentials?
Dennis, your sound dropped off.
Oops, sorry.
Dennis, you're back. Okay, just wanted to let you know. Okay.
Okay, great. Thanks for reminding. Well, so the agenda for our first part is the following. I do understand that probably many of you are already familiar with Apache Ignite. But anyway, I'm going to give a very short introduction about this platform so that everybody is on the same page. Next, we are going to explore how we can deploy Apache Ignite in different environments, how the clustering is implemented in this system, and basically what you as developer and architect need to know whenever you decide to start your first Apache Ignite cluster. Next point that will come to your mind when you architect or design your first application after the cluster is up and running is, how am I going to store my data? And before you decide how you're going to store your data, before you model your data, you need to know how distributed storage looks like, how it works, how it executes, because the more you know, the better will be your architecture and design. Finally, on top of this distributed storage, I will show you how to run the simplest applications and queries possible, which will be key value based queries. And finally, today's presentation, I'm going to finish with the brief overview of Ignite SQL capabilities that work on top of the same distributed storage that you're going to learn a lot about. Okay, so let's move on to the first thing. So Apache Ignite in-memory computing platform. What is it? So if you take a look at this picture, you will see that the main central part of Apache Ignite distributed system is the storage, memory-centric storage. And why do we call it as a memory-centric storage? Ignite historically started and was used as in-memory computing platform that stores all the data and all the indexes in RAM, in your memory. But at the same time, this capability, we know that by storing data and indexes in memory, you can get benefits of the speed and performance of your RAM hardware. But at the same time, a lot of the use cases I saw Apache Ignite used for still required the durability, because regardless of all the high availability options available in distributed systems like Ignite, you still want to have persistence enabled, just for the scenarios when your whole cluster goes down or when you cannot feed all the data in RAM, because you have a lot of historical data and you have operational data. And in Ignite, the storage, the memory-centric storage, is integrated with Ignite native persistence. It is just one extra tier that is used in Ignite. This tier allows you to store the full data set you have in your cluster, and by enabling this disk layer, Ignite native persistence, it's optional for you to keep all the data in RAM. You can keep in RAM as much data as you can afford, depending on your budget or depending on your application needs. Another option, persistence option that is available in Ignite is an integration with a third-party persistence, such as a relational database, NoSQL database, or documentary database. It doesn't matter. So if you, for instance, and this type of databases are usually used with Ignite when you already have some solution architecture application up and running, and you want to start with, and you want just to accelerate that deployment, that application, and you just plug Ignite in between your already existing database and your application layer. Well, on top of this application, on top of this distributed storage that is capable of keeping data both in RAM and on disk, you can run a variety of different queries and computations, such as you can execute key value queries or SQL queries. You can do distributed transactions. You can run distributed computations. Distributed computations in Ignite are the same well-known MapReduce-like computation we accustomed to use with Hadoop or different distributed systems. Also, there are other capabilities such as those that are needed for support streaming scenarios or machine learning use cases. But today we are going to spend more time on our distributed storage, and we are going to review key value and SQL APIs. So, but before moving to the storage internals, let's take a look how we should deploy our cluster and how the clustering component is implemented in Ignite. So first, take a look at this diagram to the right. Actually, Ignite cluster consists of two main types of cluster nodes. The first type of cluster nodes is called server nodes. And server nodes actually act as containers for our data. And since they store the data, they will process all our application requests that want to execute SQL queries, key value queries, or probably you're going to deploy and run machine learning models, and so on and so forth. The whole idea here is that the servers actually build up your distributed storage, build up your distributed database. The more server nodes you have in your cluster, the bigger volume of RAM and disk is available for you, and more workloads you can put on your system. Next, once you start your first Apache Ignite cluster of server nodes, you need to connect to it from your application sides. And as for the connectors from the application side, we have developed special kind of nodes. We call them client nodes. Those are just the nodes that you embed in your application logic. And they are used just as a gateway, as an entry point to your cluster. Basically, if you have a Java application, .NET or C++ application, you just need to provide a special configuration that by default needs to have only a networking layer configuration parameters. And after that, your application will be able to connect to the cluster that is composed of the server nodes, and the application will be able to run the logic it needs using all the APIs that are provided by Apache Ignite platform. Speaking about the deployment, actually Ignite doesn't impose any limitations on how and where you should deploy your cluster nodes. It's up to your requirement. It's up to your demands. Because the reasoning about this is because Ignite nodes are logical entities. Actually, every Ignite node is can be run as a JVM process, dedicated Java Virtual Machine process, which means that you can build and have a variety of different configurations with Ignite. Like if you take a look at this diagram, you can see that we can have 2 cluster nodes running on a single server or virtual machine. It doesn't matter. Or for instance, you can have for sure only one server or only one client, only one Ignite node running on the same server or virtual machine, again, depending on your requirements. Or even what's more interesting, since Ignite nodes can be embedded into your Java, .NET, or C++ applications, you can run how we call embed several Ignite nodes into a single JVM process. And actually, this configuration is useful, is widely utilized by Apache Ignite community for the unit testing of Ignite. So in Ignite, we have a myriad of different tests developed to check this or that functionality. And usually when we want to do, and the biggest part of the testing is being done in this mode, when we start a cluster, like say of 5 or 10 nodes, and all these nodes are running in a single JVM process. This really simplifies and shortens the overall testing process. And you also can consider this type of deployment for Ignite for your testing engine. Next, speaking about the on-premise or cloud deployment. Again, here is we also don't have and do not impose any limitation. If you prefer to deploy Apache Ignite cluster on your own hardware, then go ahead and buy that hardware and deploy your cluster across the machines you have. Or for instance, if you prefer to rely on cloud platforms such as Amazon, AWS, Google Compute Engine, or Microsoft Azure, you also are free to deploy Ignite there without any limitations. The only thing that you need to keep in mind is to give Apache Ignite nodes a way to look up each other in your environment. For instance, when you deploy on-premise, you just might need to provide a list of all IP addresses of your machines where the cluster nodes can be deployed. And this will help the nodes to discover each other at the time they will be started. Or if you try to deploy your cluster in AWS or under the Kubernetes supervision, then you also need to set up a special networking component. We call it IP Finder. That will provide a way for our cluster nodes to find each other, let's say in AWS. For instance, if you want to start in AWS, we do have a special AWS IP Finder. And that IP Finder stores all the information about all the cluster nodes connected in a special S3 bucket. So when a new node tries to join the cluster, it will open a connection to that S3 bucket, and will check up whether there are any IP addresses of the previously connected nodes. And if there is any, it will take all these addresses and you will use one as a connection point to the cluster. And at the same time, this new node will write down its own IP address in that shared S3 bucket, so that the rest of the cluster nodes will be able to look up each other on AWS Cloud. This is actually how we can automate the nodes auto discovery in AWS. And the same can be done for the rest of the cloud platforms. Well, but today we are going to use my own laptop for the cluster deployment, and I will show you how you as a developer or as an architect can start your first cluster on your local machine in a matter of a minute. So let's do it right now. So here is I have Apache Ignite distribution. I've downloaded the latest Apache Ignite release, which is 2.3. And I'm going to use a special Apache Ignite SH file. So this script actually will start Apache Ignite node. By default, what type of node and what are the configuration parameters? Those configuration parameters are listed here. We are going to take a look in it in a few seconds. So let's start our first node. And also, while this node is being launched, let me start the second one using the same configuration. Well, let's go to the configuration. This configuration is pretty simple, and we are going to use it from our application. Pre-class loading, we're going to skip this parameter for now. That will be explained during the second part of this in-memory computing essentials webinars. This one is data management memory configuration, also goes to the second part. But what I'm interested right now in is this networking configuration. Here is we need to set up. I already mentioned that if you just want, you as a developer or architect, if you want to start with Ignite and want to run the first cluster, the first thing you need to do is to make sure your cluster nodes are interconnected. And you as a developer need to know about only this component. You need to set up so-called TCP discovery SPI that allows every node to discover each other during the start time. And that discovery SPI requires from us to provide a way how the nodes will be able to look up each other. And here is, I'm just going to use so-called TCP discovery VM IP finder. That gives me a way to provide a list of all IP addresses where my nodes can be deployed. And here is I know in advance, right? So that I'm going to use my own local laptop. And I'm saying that the nodes will be running on this loopback interface, and they will be bound to one of the ports from this range. So that's all. Like if, for instance, you deploy it on premise in your own networking environment, here is instead of loopback interface, you're going to have some real IP addresses, right? Or if you're going to deploy Ignite cluster under the Kubernetes supervision or on AWS or Google Compute Engine, and you don't know IP addresses in advance, then you're going to specify a different type of IP finders we have. We have a lot of different IP finders under this section. You can find them at the end of this presentation by just walking through the documentation we have. But anyway, so that's my configuration, networking configuration. And let's go back to my cluster nodes. The first one node is started. And the second one also joined the cluster. The nodes were able to discover each other by just, using this information provided here. That's all. Now we have my first cluster nodes, and those cluster nodes are server nodes. So those nodes will be used as data storage. So actually now, having two these nodes, I can claim that I have my first distributed database running on my local laptop. That was pretty easy to do, right? And now throughout this talk, I'm going to use Ignite management and monitoring tool. Let me connect this management and monitoring tool to my local cluster by using a special Ignite web agent. And this tool is, I'm going to use the deployment of the tool provided by GridGain, but it's not a requirement. If you want, you can deploy it in your own environment. So let me double check that I could connect to my cluster. This tool is really useful for developers and architects when we start with our first applications, when we are experimenting with a distributed database and such as Apache Ignite, because we can see where we can connect, double check how many nodes we have, what are the metrics, memory usage, CPU usage, and so on and so forth. Okay, so now that's about deployment and clustering. Now let's go to the storage. Speaking about the storage, actually now you see that we have 2 server nodes deployed on my local laptop. And actually these 2 server nodes represent a distributed storage or distributed database that is a part of Apache Ignite platform. Essentially at the implementation layer, this database is a key value store. Like when you want to store data in Ignite, first you need to provide a primary key and a value that belongs to this primary key. And then by taking this primary key, or we just call it key in terms of key value operations, we will be able to locate a primary node that will host and that will keep your entry. The key value store internally, you can think of a key value store as of a distributed hash table or as of a distributed hash map. You know that those simple hash tables or hash maps available in Java programming language split the whole space available into the buckets. And then in the buckets, you store specific key value pairs. And here the idea is pretty the same. So, but instead of buckets, we have partitions. And I'm going to show you how a key is mapped to partition and how we map a partition to a specific destination node. However, internally, Ignite right now is not like, yes, we internally are represented as a key value store, but the memory architecture itself is much more complex. And the data is not stored in a hash map form on every individual node, because we split all the memory available on every individual node on pages, on pages of a fixed size, and then the data goes to the pages. And this is a bit of the insights about our memory architecture topic that we are going to discover during our second part of this series. Well, and this storage, right, again, this storage will be distributed across your cluster nodes, and it will make use of RAM and disk available there. And the disk is optional. It depends on your configuration parameters. And then on top of the storage, as you already know, we can execute key value operations, because key value operations are essential. They just are supported by default because internally we are rely on key value like storage. But at the same time, you can run SQL or you can run computations or transactions. And what's interesting about SQL, that even when you try to insert or update data using insert or update commands, those commands are still will be mapped to transformed into their key value like operations internally, because Ignite always requires you to provide a primary key for every operation you try to execute, let it be key value operation or SQL operation. Well, now let's look into the key value storage implementation. Specifically, I want to start with a simple question, because I, as a developer or as an architect, when I make a choice between, let's say, Ignite or other distributed database, I want to know how the data is going to be stored and how it's going to be processed. Because, but from the application standpoint, it's good to know about the internals because it helps us to define our architecture properly. But from the application side, everything, all the complexity detail, all the complex details about the internal implementation are hidden from you, and you just start using operations. Like, let's take this one, simple put key value operation. that you can run from your application code. And here is you might, you might be puzzled where this key and value will be sent. Like now on my local laptop, I have two server nodes, Ignite Node 1 and Ignite Node 2. Where will this update go, to the first node or to the second node? Now we don't know this precisely, but there is a specially defined algorithm that can calculate a primary node without any exception. So first, from that operation, what we need to know, we need to take a key of our value that we are trying to insert in the cluster, and then we will take a hash code of this key and we'll map this key to a specific partition file. A partition file will be explained in a minute, but then like every partition belongs to a concrete cluster node at any given point of time. And those once you are able to map, once Ignite is able to map a key to a specific partition, Ignite node in your application will know precisely where this key should go, to node 1 or to node 2. Well, but what's partition? How do we define partition? Before we start talking about partitions, we need to know a notion of caches in Ignite. Think of a cache as of a table in a relational database. It's absolutely the same. It's just a logical notion, a logical term that defines a place where we store our key value pairs. But the key value pairs are not just, we already know the key value pairs are not spread out randomly across the cluster nodes. Every key value pair belongs to a specific partition. Like here is on this diagram, we have partition 1 from this cache. And inside of this partition, we might have many key value pairs. At the same time, cache consists of many partitions, 124 partitions by default, which means that for this cache, for instance, we are going to have partition 2 as well. And inside of this partition 2, we are going to have other key value pairs. Next, all this means that partitions, there will be a lot of partitions, and all the partitions will be distributed across the cluster machines we have. Like if again, take my example, that now I have 2 nodes running on my local laptop, Ignite will automatically map partition 0, let's say, to Ignite node 1, then it will map partition 1 to node 2, partition 2 will go to node 1, partition 3 will go to node 2, and the same will happen for the rest of the partitions we have in our cluster. And then you know that inside of our partitions, we store actual data that you put into the cluster. One thing to keep in mind here is that a key and your value belongs to a specific partition all the time. A partition is never changed. This is like with a hash table, right? With Java hash map or hash table, when a key and value belongs to a specific bucket. And here is in Ignite, every key belongs to specific partitions, but partitions can be rearranged across the cluster during its lifetime, because instead of 2 nodes at some point of time, I might have 3, 4, 10 nodes. And to distribute the data evenly and to distribute workloads, I need to distribute the partitions too, because I want to data to be distributed across all the cluster nodes I have. Well, and now if we were supposed to answer this question right now, keeping in mind this information, that key is mapped to partition and partition belongs to specific node, where would this key go? Again, this depends on a value of your key, and specifically on the hash code that will be generated based on this value. But probably we had some key which hash code was mapped to partition 2. And we know Ignite application, Ignite knows that partition 2 is located on node 1, and some specific key will be sent to this partition. Pretty simple, right? Again, another topic that you need to know about the distributed storage. Let's imagine that now we have 4 nodes, and we have 4 different partitions, numbered from 0 to 3, like on this diagram. And then at some point of time, something unpredictable happened, and we lost one of the cluster nodes. And if you look into this picture, you will understand that after we lost that node, we lost partition 1, which means that we lost all the data that was located and stored in this partition. That's something that is specific to distributed databases of any kind. Whenever you start distribute your data, you might lose your data if you do not care about backup copies of your data or replication factor. Because the more dependencies, the more nodes you have, the chances that the topology that the nodes will die or will join the cluster, the chances increase. So, and in Ignite, to address this issue, this specific particular problem, you can enable or increase so-called backup copies or a replication factor in terms of other distributed databases. Like again, let's go back to the same scenario. Now we have the same for nodes, and we have partitions, 4 partitions. And then I said in my configuration that I want to have backup copies for every partition, meaning for every data I have in my cluster. And the backup copies was arranged this way. Like now I have backup copies for the same partitions in other nodes. And now if we try to reproduce the same situation, if I lose the same cluster node, it will not mean that I will lose the whole partition 1 or partition 0, because we have a copy of partition 0 and partition 1 on the other nodes, which means that it's absolutely fine to lose this node with all the data it's stored, because now still in my cluster, I have all the partitions I need from 1, 0, 1, 2, and 3. And here is this node will be just promoted to the primary node, and it will become a primary node for partition 1. And then Ignite automatically will elect another node among the 3 left, who will store a backup copy of this partition 1. And the data will be rebalanced again automatically for you. You as a developer and you as an architect here is just to need to configure the backup copies or replication factor in advance before you deploy your cluster. That's it. The rest of the work will be done by Ignite, such as partitions distributions and data rebalancing when the cluster topology changes because of node failures or when you add new nodes to the cluster. Okay, so now let's try to see how we can make use of this information. So we have still our 2 server nodes running on my local laptop. And let me connect from an application side using the simplest application we can build with Ignite that will use put-get operations. Here is actually what I'm doing. I'm enforcing the client mode. I will start this application and I want this application just to embed Ignite in its own process and use Ignite client node as a connection point to my cluster. And here is I am providing the same configuration we used for server nodes so that my client application is able to discover the nodes in the cluster. And next, my client application is going to deploy the first cache, right? So the first cache, the first place that will store my data sets. And once I deploy this cache in the cluster, I'm going to put some data using this primitive operation, cache put operation, the simplest operation possible. I'm going to generate keys from 0 to 40, and I'm going to generate a random value for these keys. And then I'm going to do a reverse operation. The goal of this operation is to read the data back and to confirm that the data is in the cluster. So let's start this example. While the example is being studied, also here is what to mention here is, again, just to summarize on the information you learned so far. When we deploy this cache named by the name of this example, will be split into 1024 partitions, and these 1024 partitions will be evenly distributed across the 2 server nodes I have. And then when I'm going to put data into my cluster, every key will be mapped to a specific partition. And once we find out the partition, a key and its value will be sent to the first node or to the second node, depending on the partition value. Well, so let me check. Yes, the example was executed successfully. So we run it, we stored all the values, and we confirmed that the value, that all the data was in the cluster. And here is, let me see that I'm going back to the My Monitoring tab. Here is, I can see that here is my cache. I have only 40 entries, and all the entries are stored in primary partitions, guys. So we can see that there are no any backup copies for our data, which means that if you recall my previous slide about the backups, now if I try to kill one of the cluster nodes, then I should lose the data. Let's try to reproduce this scenario. Okay, that will be our victim. Let me kill this node. Okay, the node is no longer up and running. And now I want to run this example. And I'm going to read the data back only. And my expectation is that the application will not find some of the values. And also we can go back here. Here we can see that now we lost 11 values. So we lost probably a half of the partitions. And in those partitions, we stored 11 values. So some of the entries are missing now in our cluster. Let's take a look what their application reports. Right, so here we can see that we lost the value for a number of keys. How do we fix it, right? Again, if you recall the previous details I shared with you so far, we need to increase the replication factor to make sure that all the data is located in that there is a backup copy of every partition and every record is stored in my distributed storage. Okay, let me bring back my killed node. And now what I want to do, I want to configure the replication factor for my cache. It's easy to do. Cache configuration, again, I need to do this cache configuration. I am going to use the same name. And in Ignite, if you want to set and the replication factor, you need to use set backups method and set it to 1. It will mean that for every record, for every partition, there will be one primary copy and one backup copy. Well, and now I want to start the cache with the same configuration. I want to populate the data, sorry, and want to read it back. Okay, so now let me kill this cache because I changed one of the major parameters. I need to redeploy the cache completely. I can kill the cache from the management and monitoring tool. Okay, the cache is killed. You can do this from your application, but I just want to do it quicker from the management tool. Okay, now let's quickly run the same example. Again, now we have 2 server nodes. We do not have data. Now this application will preload the data. But now we set this replication factor, number of backup copies, to 1, which means that actually every node will store a copy of every record. Now, if you go back here, we can see that now in cluster in total, we have 80 entries and kind of 40 unique entries. All these unique entries are stored in the primary partitions across the cluster, but also for every partition, we have a backup copy of this partition, which means that for every record, we have a backup record. And now it's safe to lose any cluster node. Let me go ahead and kill this node. Again, I killed this node, and now I want to start the same application. No data preloading. I just want to be sure that the data was not lost because I used the replication factor. while the application is being running. Again, here is I can see that we no longer have backups, which is fine because I have only one cluster node in my deployment, but all the records are here because before this node, that is the only one that is left, stored the backup copies of my partition, and the same data is still here. And now when I run the same example, I can see that I can read all the data back. Well, this is how simply, so this example shows us two things. First, how it's simple to connect to my cluster from Java application. It's just, you just need to provide the configuration that stores networking parameters. And then you can do whatever you want with your storage. You want to use it as a storage, as a distributed database. Here is I deployed some cache, I preloaded some data, and also we found out why should we care about the replication factor, right? Because it's a distributed database. There are many nodes, and we need to protect from failures, from node failures. Well, let me start the node back and switch back to my slides because we are going to the SQL capabilities. So now that example, the latest example, showed us how to use key value operations, right? So it's simple. You just need to give us a primary key and the value you associate with this key. However, wow, what happened? Why did I? Okay, here it is. But key value APIs are good when you know a primary key in advance and when you do not need to do some advanced filtering. But what we can do about more advanced queries? And here is Ignite decided not, to reinvent the wheel, making out its own advanced querying engine. Here is we decided to take another path, and we decided to support distributed SQL. So speaking about SQL, again, we are going to use the same. Here is we are talking about the same cluster. The data will be stored in the same key value storage. We just can, store indexes close to the data on the server nodes. Yes, the key, the values itself, the records, will be stored in the form of key value pairs, but also we are going to have indexes for every kind of primary key or for every secondary key you define. And as well as data, indexes are also distributed across a cluster of nodes you have. And speaking about SQL APIs, for sure we do support all the data manipulation language commands, such as select, updates, inserts, and deletes. At the same time, if you want to configure your cluster, and if you want to define your SQL schema and tables using data definition language, you are free to do this because Ignite presently supports data definition language. And presently we provide you commands such as create table, create index, drop index, and alter table column, and many, many more. And we keep improving this part. What was also good about Ignite SQL capabilities, now you saw that we can connect to our cluster from Java application, right? Using Java client node connection. And actually our .NET and C++ users can do the same for native .NET and C++ applications. But what to say about other languages, such as Python, Ruby, Node.js, JavaScript? Ignite presently doesn't have any native clients developed for these languages. But since Ignite supports SQL queries, you can connect from those languages using Ignite's JDBC or ODBC drivers. And you can work with Ignite with any other SQL database without any limitation. And the same, and also JDBC and ODBC drivers supports the connections from your tools that you use for analytics or BI, for instance. Well, speaking about the connectivity again, now we know that you can connect to the cluster and issue SQL queries using JDBC or ODBC, or for instance, also the REST protocol is available for you. And as a Java, .NET, and C++ developer, you can also run SQL commands from your Java applications directly, you don't need to use JDBC driver, for instance. That's again up to you. A lot of choices, and actually the solution is flexible here. Once you connect it to this cluster, you can define your tables using and your indexes using create table, create index commands, and also you can change the structure of your tables and indexes later by the usage of drop table commands or alter table commands. So for instance, and one thing to note about Apache Ignite is that when you create a table in Ignite using data definition language, like create table city, shown on this slide, we are going to create not only, we are going to create two things. The first, we are going to create a distributed cache that we discussed so far. And you know that every cache is split into partitions, and inside of partitions, we are going to store data. And on top of this cache, we are going to define an SQL table, actual SQL table, that will be used as a reference for our SQL queries. When we decide to run an SQL query, and the SQL engine, Ignite SQL engine, will use the schema defined, the SQL table defined with all the columns you listed in your specific command. But here is also, don't think that we support several copies, right? Here is the table is just, logical thing in Ignite. All the data is stored in cache, but the table is just the way for to convey to Ignite SQL engine the structure of your data that is located in distributed cache and how you can query the data with SQL commands. And final thing about SQL language is that whenever you modify your indexes, for instance, you can create the index in real time, or you can drop the same secondary index in real time, and all this information will be preserved if you use Ignite native persistence. Which means that you do not, if you restart your cluster, you don't need to re-execute the same set of commands once again. All this information will be persisted on disk, and once you just restarted your cluster, you are good to go and you're good to run the applications without any additional steps, configuration steps. Well, and finally, when you define your data, your SQL schema, you can start using SQL queries from your applications. And Ignite supports ANSI 99 specification. All the queries are fault tolerant and consistent, meaning that if you run an SQL query and your topology and your cluster topology changes in parallel, your query result will not be affected. Ignite will be able to re-execute a part of the query if some of the nodes was kicked off the cluster. And the whole point here is that you don't need to worry about it. We do worry about consistency. And also speaking about the queries, selects for selects we do support aggregations, filtering, and what's more important, we do support subqueries and joins. I'm going to give you more details on joins and subqueries in the next in the second part of our webinar. But today I'm just going to show you how you can run them easily from your application side. The details are to follow in the next session. So what I'm going to do right now, quick example, just a really pretty quick example how we can use SQL capabilities in Ignite. Ignite goes with a special SQL line tool that is available with every Apache Ignite release starting 2.3. So it's located in the bin folder of Ignite. And I'm just going, and this tool actually is a free tool that is available and used by many other SQL-enabled databases. And here is I'm just going to connect to this tool using JDBC driver. So I have my local cluster. Here is I have two of my server nodes, and I'm going to connect to the server nodes from this tool. Okay, I've connected. There are no any tables. So, and I prepared a special script for you guys. So that's one of the basic scripts that is going to define a database for countries cities that are located in specific countries. And for every country, we will have a country language, the inhabitants of the country speaker. And also I'm going to define some secondary indexes, and then I'm going to put the data into my cluster using insert commands. Pretty simple. We are going to take a look at the with statement in our next session again, because I'm going to explain you affinity collocation and joins, how they work and what you can do to make them fast in your applications. But here is just the goal is to demonstrate that you can easily run any SQL related commands in Ignite. Okay, here is, I'm going to run the script I've just shown to you. We define the schema now, we're putting data into my cluster. Again, if you go to the monitoring tool, here is I see once I executed every create table command, I did two things. Ignite created underlying caches. The caches store actual data. And on top of this data, we defined our SQL table that will be used by our SQL engine to process SQL queries that we are going to run. Okay, so the data is there. Now we have tables, which is right. Now let me run the first query, like select, I want to get the most populated, the 10 most populated countries in the world. And here as we can see that China, India, and United States take the first place. And at the same time, for sure, in Ignite, we can run distributed joins. For instance, here is I have, I want to select data, I want to select country name, I want to get actually the most populated cities in the countries such as United States, China, and Russia. So 3 most populated cities. And absolutely to accomplish this query, I need to be able to join the data, right? And Ignite can do this for you, right? Here as we can see that the most populated city turns out to be Shanghai in China. Then we have Moscow from Russia, and New York takes the 3rd place. Well, good. The details about distributed joins, implementation, and affinity collocation are to follow in the next webinar. So that was pretty easy, right? So here is now you could see how we can actually connect to the same cluster we had before, how we could quickly create an SQL tables with caches, populate data, and start querying this from our applications. Well, finally, that actually, guys, all for our today part, for the first part of our in-memory computing essentials. But what can you expect to hear from me during the second part, during the second presentation? So again, I'm going to dive into the internals of affinity collocation. I'm going to explain you what this term means and how this term is applicable to distributed databases and in-memory computing. Because if you kind of know all the advantages of the affinity collocations, you will be able to execute efficient distributed computations, and you will be able to use distributed SQL in Ignite also efficiently. Because affinity collocation is also tied up with our distributed joins, and I will give you some insights on this. Next, I will finalize the second part, speaking about machine learning capabilities that were added to Ignite, that have been added to Ignite recently, and this component is being improved over the time. And finally, at the end, I will finalize reviewing memory architecture and persistence. Today, we took a look at our distributed storage, distributed database from the high-level perspective. So we found out how that all the data is stored in caches. Every cache is split into many partitions, and inside of partitions we store key values, right? But when a key value goes to a specific partition, it will be located, will be stored in some way in memory and on disk. And I'm going to show you how the memory architecture on every node looks like, how we take your RAM space, how we split the space in pages over the fixed size, and how all this is integrated with our persistence, and how we make use of B+3 data structure. All this will be presented to you on Wednesday, December 13th. So also make sure to join us. And as for today, having said this, I would like to thank you for joining this webinar and ready to answer on several questions.
Okay, so there's some questions, and audience, if you do have a question, go ahead and enter it in the GoToWebinar control panel in the question section. And the first question is, what about transactions? Can caches be transactional, and can SQL operations be transactional?
That's a good question. So yes, Ignite supports transactions, distributed transactions. All you need to do if you want to make a cache transactional is to define a special configuration property. Let me quickly show it to you. Here we have the same example where we set a number of backups to 1. And at the same time, we can set atomicity mode to transactional for this cache, which means that once you set this configuration parameter, all the updates that will come to this cache will be transactional. And as for transactions, you can run transactions across several caches. For instance, if you want to update countries and cities inside of a single transaction, you can easily do this with Ignite without no limitations. Speaking about SQL, all the when we speak about transactional operations, we assume key value operations. When you precisely know a key and that you're going to update or that you're going to update inside of your transaction. But SQL presently is not transactional. To make it transactional, the Ignite community has been working on multi-version concurrency protocol. And you can expect to get the beta version of the multi-version concurrency protocol by the end of this year. And the plans of the community is to roll out the GA release of MVCC in Q1 or Q2 of the next year. So just keep an eye on the discussions happening on Ignite dev list. SQL will be transactional pretty soon in Ignite. Next question.
Next question. Is it possible to read and write data between Apache Ignite and a relational database system? For example, load data from the database to Ignite cache, do some processing, and save the output to the Ignite cache, and then back to the relational database management system.
This works automatically in Ignite. So if you use a relational database as your persistence layer, then Ignite will automatically keep in sync your in-memory storage with your relational database. Whenever you start, let's say, whenever you update a record in Ignite, this update will be propagated to your database automatically. So you don't need to worry about here. We do support 2 modes. We support synchronous mode, when an update will be completed only when it was updated both in your database and in Ignite, or we can do this asynchronously. So first the update will be completed and stored in Ignite, and then over the time it will be synced to your relational database. But the only thing to keep in mind here is that if you want to use a relational database with Ignite as the persistence, and you want to run SQL queries, then all the data must be preloaded from the database to your Ignite cluster, because Ignite SQL engine cannot run SQL queries over third-party databases. However, this limitation is not, we do not have this limitation for Ignite native persistence, where the Ignite native persistence doesn't require you to have all the data in RAM if you want to run SQL queries. And this is something that we are going to discuss in the next during the next webinar.
Okay, I think we have time for 2 more questions. The first one is, does the index get corrupted, and if yes, how would you recover them or recreate them?
No, I cannot say that no, an index can be corrupted probably only if you use persistence, but by default, no. So actually, in Ignite, if we talk about memory, so if data is in memory, then most likely you just need to restart your cluster. But if you take the example with Ignite native persistence, when an index is stored both in RAM and on disk, and for instance, your hardware or your disk hardware just won out and caused data corruption, here is you need to use snapshotting capabilities or backups. For instance, Ignite doesn't support this right now, but GridGain provides distributed, gives you a way to do full cluster snapshots. So you can make a snapshot out of your data stored in the cluster, and then if your data or index is corrupted, you can recover your cluster using a snapshot.
Okay, and last question. And audience, if I didn't get to your question, I will send them all over to Dennis and we can do a follow-up blog post to address the rest of these questions. So the last one is, if my relational database gets updated through another means, will that data be propagated back to Ignite?
Now here's you need to write your, you need to develop, develop code that will take care of data propagation from your relational database to Ignite. Like I do know that, for instance, GridGain provides Oracle Golden Gate integration that will do this automatically for you. But also you can use probably some other third-party solutions that will set up a kind of a sync up link between your relational database and Ignite. Otherwise, you should do this on your own by sending all the updated, all the changes from your relational database to Ignite cluster.
Okay, and that brings us a little past the hour. Audience, thank you so much for your participation today. Please go ahead and register for part 2. We look forward to seeing you in December. Dennis, thanks for a great webinar today.
Thanks, Alisa, and thanks everyone for joining me. Look forward to see you at the next webinar. Goodbye.
Bye-bye.